Hey, welcome to a new app. In this app, you will be analyzing a book. So I'll give you the text file, which contains the entire text of the book, and you learn how to run different analyses on this book with Python. And with that, you learn how to use regular expressions and sentiment analysis. I'll explain you what these two concepts are. So the analysis practically will consist of things like extracting information from the book, such as finding out how many chapters there are with Python, finding out the most used words, finding out how many times a certain word was used. So all these things you can do using regular expressions in Python. So extracting information with regular expressions. Then we will find the mood of the chapters, if they are positive or negative. So if the text has a positive attitude or a negative attitude. And that is part of sentiment analysis. So we will do that with Python as well. Right, so what you need to do for now is please download this text file, which I've attached in the lecture resources, and also create an empty PyCharm project. And I'll see you in the next video where we will start coding. See you there. Before we begin using regular expressions inside Python, I want to make sure you understand what regular expressions are in the general sense, because regular expressions are not only used with programming languages, they are also used in other applications such as word processing apps, for example, Microsoft Word or Google Docs. So in this video I want to give you an example how regular expressions would be used in a Google document. You don't need to do anything, you can just watch this video. You don't need to do what I'm doing, just please follow me. So let's say we have this text in a Google document, and this text is made of different chapters. And let's say we want to count how many chapters we have, how many of these we have. So chapter 8, chapter 9, chapter 10. To do that, you would go to edit and go to find and replace and perhaps search for chapter, right? And then we see that we have 5 of them, but there are 3 only here. So this find operation is not enough because it's not telling us the exact number of chapters here. It is also counting that word chapter there and this word chapters here in the total number. And that's where we get the help of regular expressions. So regular expressions are integrated in word processing apps such as Google Docs. For example, you see here, you can check this box. Now, match using regular expressions. And then after chapter, you make a space. And then you write the regular expression with square brackets, open and close square brackets, and write 0 to 9. Now you'll see that we get 3 results. And that part here, that is a regular expression. So this was able to capture chapters together with the numbers. So regular expressions are a language that lets you create patterns to locate texts. So this language can be written inside other apps such as Google Docs, but it can also be written inside Python, as you'll see in the next videos. So in this case, this tells us to capture the chapter and the space and then any number from 0 to 9. We'll talk about this more in depth in the lecture video, so I'll not go deeper into explaining what this means now. So this was just to give you a general idea of what regular expressions are. Of course, when you use them in Python, you are more powerful on what you can do. The capabilities are immense. The things you can do are infinite in Python. You can analyze text and then you can display that text on a website. You can send it by email. You can do anything. So let's dive into Python in the next videos where you master regular expressions there. See you there. Hi, in this video we will load the book file to our project directory and we will run some simple analysis using regular expressions. So let's start. You need to go to the lecture resources in the previous video or in this video, and you'll find the file named miracleintheandes.txt. So please copy that and place it in a PyCharm project. So let me quickly introduce you to this file. So the file contains the text of an entire book. The book is titled Miracle in the Andes. It's a tragedy and a miracle as well, and it's written by Nando Parrado. Now the book, the text, is structured in chapters. So for example, it starts with chapter 1, so you have the chapter label and the number of the chapter, and then once this chapter finishes, then you have another label, chapter 2 or 3. So chapter 2 was somewhere here, chapter 3, and so on. So it has 10 chapters in total. Now, where do we do the analysis? Do we do them in a .py file, or should we create a Jupyter file? Well, it's a better idea to create a Jupyter file and work on Jupyter, because when you do analysis, Jupyter offers a better structure with cells, and it allows you for more efficient analysis with Python. So please start Jupyter. You can do that in the terminal inside PyCharm. And run the command Jupyter space lab, and I've introduced you to Jupyter earlier in the course, and I've shown you how to use it. So that should open the browser pointing to the Jupyter app. So since I opened that from the command line in PyCharm, and the command line was pointing to the app book analysis directory, which is this one here, that means now Jupyter in this directory, it's showing me the local files I have in PyCharm. So that's the same directory with this one. That means I do have access to this Miracle in the Andes file. And in this directory now I can create a Jupyter file. So you see that untitled.ipynb was created in here. And it should have also been created in here. So it's good to have a PyCharm project as well for this Jupyter file, so that you can basically organize all the files in this project, even though we are working on Jupyter. Right, I'll rename the file book_analysis. Right, so let's import pandas. Oh, maybe not. So that was a joke. You cannot use pandas for analyzing a bunch of texts. So pandas is used when you have well-formatted data, right, with columns and rows, but this is just text. It is unstructured text, and you can only extract information from this text using regular expressions. So we will not be using pandas here. It is ideal that when you get some data, they are well structured in columns and rows, but that is not always the case. For example, in here, this is a book, and perhaps later on when you work in your career, you'll have badly structured data as well, which are not in columns and rows, and in that case, you might also want to use regular expressions. You will have to. Now, regular expression techniques work on strings. That means we need to load the text of the book as a string. So with open this name of the file, you can start typing it and then press tab to autocomplete the name of this file. And you need to open it in R mode for reading as file. And let's create a variable called book is equal to file read. Press Ctrl Enter, then press B to create a new cell, and here you can call that variable to see if you actually loaded the book correctly. So this is type string, right? It's just a string. Now, this was about loading the file. So let me press A to add a new cell on top, and here write the title of this, load the book. Escape M, enter, to make it markdown cell. It's not a code cell, it's a markdown cell. So when you press escape and then press M, you turn that into a markdown cell and then you execute it to show it as a title. Now we're going to ask a few questions about the book. For example, let me create another markdown cell with M, enter the cell and write how many chapters. So how can we calculate how many chapters are there in the book? We can do this two ways. We can use string methods or we can use regular expressions. Let's try first with string methods. Let me create another markdown cell. I'll do this small text with 3 hashtags with string methods. You can also press Alt Enter or Option Enter on your keyboard to create a new cell on the fly without having to press Control Enter and then B. So with string methods, how can we calculate the number of chapters? Well, we could do something like book.count chapter, because we know that in the book we have these labels. So chapter 1, then we have chapter 2 somewhere else in here. There we go. And so on. So if we count the number of those chapter labels, but be careful, it should be with a capital C, so things are case sensitive here. Remember, if you want to search for something, you want to type that name exactly as it is, respecting the case sensitivity of letters. So with that, if I execute, I get 11. But the book only has 10 chapters actually. It does not have 11 chapters. So the last chapter is chapter 10. Why do we get that then? Well, we get that because somewhere in the book, if I search for chapter here, somewhere we have this chapter string where the author has said something that mentions the name chapter. So this is not actually accurate. It's not the accurate method to get the number of chapters, because we do have 10 chapters, not 11. And that's where regular expressions come into help. So now I'm going to do this with regular expressions, or also called regex. To use regular expressions, you need to import the regular expression library for Python called RE. This is a standard library, so you don't need to install anything. And in another cell, perhaps, once you execute this, in another cell, you want to create a pattern variable. And that will be equal to re.compile. So a pattern now is a string which you provide to the compile methods. And this string should tell this library what pattern you are looking for in the text. What pattern do you want to find? And the pattern is chapter, a space after the chapter, right? Let's see. Let's find the chapter here to explain you what I'm doing. So we need to find this pattern, right? So that is chapter with a capital C, then we have a space, and then we have a number. So see now what I'm going to do to tell this library that it should look for numbers. So you write 2 square brackets. So we're working inside the string always, right? And inside the square brackets, you'll write find me numbers from 0 to 9. So basically digits, not numbers. Because we can have number 10. So this will find any digits from 0 to 9. That means if we have chapter 1 in the book, this will match that chapter, chapter 2, chapter 3, chapter 4. So Let's keep it like as it is now. We need to improve it further, but let me show you the complete code, how to actually get the number of chapters in the book. So once you have the pattern, this pattern for now is just a pattern object, right? It doesn't look anything nice. So all we have done is we created a regular expression pattern object using the compile method. So this is not a string, it is a special object. Now with this pattern, we use the find all, so re find all. So this is a method and it expects a pattern object. So we apply that pattern here in here. And it also expects the text where to look for that pattern. So basically this is saying that, oh, look for this pattern in this text. So book is the text we have declared in here. If I execute this with Control Enter, we're going to get a list of all the chapters that were found in the book. So these are the chapter labels with their numbers, right? Like chapter 1, chapter 8, and so on. However, we do have an issue here. For the last chapter, which is chapter 10, this pattern was only able to capture chapter 1, because this part only capture one digit after the space. So it captures chapter, the space, and then one widget. If you want to capture multiple digits after the space, you want to add here a plus. So the plus indicates that there might be more than one digit in here after the space. So more than one digit could be after the space. And that means if I execute this now, this will also match the chapter 10 pattern now with that plus. So that means I can just apply a len function in here after this, or just store this findings in a variable, right? Findings is the list, and then you do len findings to get the number of chapters. So that answers that question. And that's the power of regular expressions, so they are more accurate than simple string methods. Now let me go once again over this pattern to make sure you understand it. So the idea is that if you want to match a literal string, like you want chapter as it is, chapter and space, you write that string directly like this. But then here you cannot just do give me chapter 1, because that would give you the literal string 1, right? You want something more dynamic, and dynamic patterns are written inside square brackets. And so inside the brackets you have this special syntax. For example, you say give me the digits from 0 to 9. If you had some letters you wanted to capture, you wanted to match after the chapter, let's say the chapters were something like chapter A, B, and then something else, then you do here something like A to Z. That's the code to match any of the letters from A to Z, so A, B, C, D, F, G up to Z, one or more times. I can actually do a simple test here, so I can save this file with Ctrl S or Command S and then execute this, and we should get 1, but we got 0 because be aware that this book variable is still holding the old Miracle in the Andes because we didn't execute this cell, right? To get the new book with that AB update, then you want to execute this cell again to load the new string. So once you execute that, you'll have a book which will contain that chapter AB part as well. And then you go here and you execute that and you should get 1. So findings is a list containing that chapter only, which contains letters after this literal string here. Yeah, that's the idea. That's an introduction to regular expressions. I'm changing this back to 8 as it was, and go here, change it 0 to 9, execute the loading of the book part, execute this, len findings, and that completes this lecture. We're going to work more on regular expressions throughout these videos, so you can get a complete knowledge of how to do regular expression operations with Python. So I'll see you in the next video. Thanks. In this video, we will have a deeper look into regular expressions. And to do that, we're going to answer another question on the book. And that is, which are the sentences where love was used? So we will find the list of all sentences that contain the word love. Let's do that. Again, we need to create a pattern object. Now, just a note, if you close Jupyter Notebook and you just open it as fresh, then you need to run all the cells with this button in here so that the book is loaded and the regular expression library is imported, because we're going to use the book and RE in this cell, so they need to be executed beforehand. Otherwise, you'll get an error. So with re.compile, we will create another string. Now, if we just say love in here, because we want to capture a literal string, right? So if we say findings is equal to re.findAll, so we're using the same method which we used in here as well, find all pattern book. Let's see what findings will be. So it's a list of the love strings, right? This is not what we're looking for. So we got this because that's what we asked for, right? We asked for love, we got love. No, what we need instead is a sentence, right? So we don't only need the love string, but we also need the part which involves a space between love. So for example, let's say we want this sentence here, right? So in that sentence, there's the word love, but then you have a space in front, and then you have other letters. So yeah, up to here. So the entire sentence is this. So we want to match that entire sentence. So before love, we have a space and we have some letters, right? So we have a space. Let's zoom in. And we have letters, which can be anything. They can be A to Z, small letters, or A to Z, big letters. Same goes after love. So you can have a space, and then you can have, well, you might also have commas here, but we'll fix that in just a bit, or you might have periods here, but we'll think about that in just a bit. So let's suppose we have this, and we can have this 0 or more times. So we can have 0 or more letters in here. Same here, 0 or more letters. So that plus was 1 or more digits or letters, whatever we had here. Now this stands for 0 or more. So there can be 0 or more letters after the space here. Let's execute this. Yeah, we're doing better. So we got this, for example, passionate love for, but we didn't get the exact sentence, the full sentence. So if I search for this here to find it where this is, so it's here. And the full sentence is from here up to here, right? Why didn't we get the full sentence? Well, because you see, before passionate and after for we have spaces, right? But all we told this compile method to find was letters, right? Inside these brackets you can also add a space, right? And if you execute this now, you're going to get longer versions of the sentences, but yet we are not there yet to get the complete sentence. So we are also counting the spaces. Let's find this sentence actually, where it is. So it's here. We got it from here to here. And it stopped here because we are not counting on the commas. So if you want to count on the commas, you can also add, after the space, you add a comma in here. So in other words, we're saying here, find me any number of letters or spaces or commas. So any number of those elements. So with that, now we have a more complete view of the sentence. As a young man, of course, I could put these things in words, etc. But this is not very sustainable because we have to count on many punctuation symbols here. We could have like a semicolon, maybe a colon, so we need to add all these. So what we could do instead is we can use a negation. So basically we can say, give me everything but the period. So this means not the period. So match every letter. It can be a letter, it can be a comma, a semicolon, but it shouldn't be a period, right? Because if it's a period, then it's part of the other sentence. So we don't want to capture that. We want to capture from love up to everything, but not the periods. So if I execute that, we're going to get the same result basically for this sentence. So that's a sentence, and that is a better way to do it. And we can do the same on the other sides in here, right? Execute, and we get this up to here. So this is somewhere at the end of the sentence. We can check it in here, yeah, and our lives down here. So if we want the period as well, then you say here at the end, so give me everything and a period. So the period is like a literal string, so it's outside of these brackets. So execute that. Now the period is included in the sentences. So that's one sentence. Let's check the other sentence. Guido and I grew together playing soccer. So this is ending in here as well. Let's see how many sentences we got. So check the len of findings, and that is 49. Now, I know there are more occurrences there because in certain occasions you don't have a space after love, but you have a comma, for example. Love, a comma. Let's say this sentence here has not been found by the regular expression pattern because the pattern is looking for spaces after love. So perhaps here we also want square brackets to create a dynamic pattern, and that would be something like, give me everything but letters from A to Z, or A to Z, capital letters or small letters. So we don't want letters after love, so we don't want one or more letters, right? If I execute this, we will get 67 now, right? So things like this here with a comma is also included in the match. And let's do the same. So we get that pattern and place it here instead of the space. So give me everything but letters, 0 or 1 or more time before love. Press enter, And yep, that's what we've got. So 67, because usually before love we only have spaces. So even if you just leave a literal space, it's fine. But to be on the safe side, just say that. Even though you're never on the safe side with regular expressions, because they are not an exact science, so there's always room for errors with regular expressions. In an ideal world, you'd have the data in a well-structured format. So with regular expressions, you basically try to do your best to extract the information you need. So the findings are these now. And to get rid of this space, we can also do something here. We can say here at the front that the sentence should have a capital letter from A to Z. And this should be one time only. So A to Z one time. In curly brackets you write 1. So that is 0 or more times, that is 1 or more times, and that is exactly 1 time. You can write 2 here or etc. So the idea is that every sentence starts with 1 big letter. So that's what we do here. And press enter. And now you see that it matches exactly where the sentence starts. And that's a very complex regular expression that I wanted to cover in this video. So that should give you a good solid base of regular expressions with Python. You know now what you're doing, you know what regular expressions offer for you. So basically you use the compile method and the find all method to extract pieces of text from a big text. So with that, thanks for following. We'll do some other types of analysis in the next videos. See you there. Hi, in this video we'll go further and practice regular expressions, and that will clear any doubts you might have about them. So in this video we will answer the question of what are the most used words in the Miracle in the Andes book. How can we find that out? Well, you should think about the data source. Where do you start? So you are working on words, but all you've got is a string, one single string. And so you need a better data structure. You need a list of words, not a string of words, because that allows you to do calculations on the items of that list, on the words of that list. So to get the list of words, you can use the split method. It's a string method. But there is a problem with the split method because, for example, you see October here is found together with a period because the split method splits the book text at the spaces, at white spaces. So you have October here, but in another occurrence, October might be without a period. And that means October with a period and October without a period will not be counted as one word. They will be counted as different words. And that is not what we want. So the split method is again not enough to get accurate results. So we need to use regular expressions again. So let's create a pattern object using the RE library. So make sure you have imported RE previously in the cells, and make sure that if you have just opened Jupyter, make sure to run that all the cells. So re.compile. And here we've got to enter a pattern. So previously in the previous video, we found all the sentences that contain the word love. So that matches a sentence, right? And this here matches a chapter followed by a number. Now we want to match words, and that would be A to Z or A to Z. And then findings is equal to re.findAll pattern book. And let's see what findings are now. So with that, we get letters, because what we have told this compile method to do is to find one single letter, which could be a letter from A to Z, a lowercase or uppercase, one single letter. But what we want to do is we want to say, give me at least one or more letters. So we need to use that plus. Press again, enter, and this time you're going to get all those words as a list. We can improve this by working on the lowercase of the book, because otherwise a word such as Friday here and another word such as Friday in lowercase could be counted as different words. So if you work on the lowercase version of the text of the book, then you are converting all the text in lowercase letters. So that means you are comparing lowercase letters against lowercase letters. That means you'll get more accurate results. So press enter, and yeah, now we get this. And the length of the findings, so the number of words in the book is this 86,798 words. Right, but our question is, what are the most used words, right? So this gives us only a list of words, and these words are repeated. So we should now figure out a way to count the occurrences of each of these words in the list. So let me just print out just 5 of them, because it would be too much here. And then in another cell, we want to iterate for words in findings. So we want to iterate over that findings list, which looks like this, right? So for each word, then, we want to end up basically with a dictionary which will look like this. Let's say chapter, 3 occurrences, and then we have before, 5 occurrences, and it, 56 occurrences, and so on. So we need to construct such a dictionary. Therefore, in here we start with an empty dictionary before the loop starts, and then we go through each word. For example, for chapter in findings, and then we say the chapter, so words, that means chapter, for example, or before, or it, is equal to the word plus 1. Now, what I'm doing here basically is that I'm iterating over this list, and then I'm adding the chapter words, the chapter string, as a key in the dictionary. So that adds the chapter key, and its value is going to be the current value of the count, which could be 0, plus 1. So let me execute this to see what we got. So we get an error. It says key chapter, because in here at the first iteration the key chapter will not exist. So we say here if words, if chapter in d.keys, so if that exists, then we do this. Else we do d word is equal to just 1. So execute this, a new cell, d is now this dictionary. So there we have the chapter and the occurrences of the chapter word before, the occurrences of the before word, and so on. Let me explain you how this loop works. So again, d is equal to an empty dictionary. Then we go through the findings list. For example, we get the chapter for chapter in findings. If chapter is not in the keys, this will be executed if it's not in the keys. So we will add 1 if we just met the chapter words in the loop. Otherwise, if we have already added the chapter to the dictionary, then we will add +1 and in each other occurrence of the chapter, right? So we will add that 1 plus 1, it will be 2. In another loop, it will be 3, and so on and so forth. So then we end up with this, and then we want to say dlist is equal to, now we want to sort this dictionary. But to be able to sort it, first you need to convert it into a list of tuples, a value key for key value in d.items. So dlist will be this now. So it's the same data as we had in the dictionary, but we have this list of tuples now. Because this now allows us to apply a sorted method, right? Like this. And then we have all the words and their occurrences. And to make this reverse, you say reverse is equal to true. And there we go. So the words has this number of occurrences in the book and has this number of occurrences. And so we have very common words, and then we have things like Roberto, which was the best friend of the writer who writes the book, so he mentioned him a lot of time, and so on. So this was a list comprehension, and basically we did construct this list using tuples. So this list will contain multiple tuples. Each tuple will contain the value and the key of the dictionary for key value in the items. So we're going to the items of the dictionary, to each key and value, and we are creating a value and a key in that list of tuples, and then we sort out that tuple. And the tuple will be sorted out by these numbers, since these numbers are the first in the tuple, right? That's why we wrote here value key and not key value, because if we did that, this will be sorted out by the keys. You see zones, the Z is, and then Y, and then we have X and W. So we want value key here. And there we have that. So with that, we have answered the question of what are the most used words. So there we go, these are the most used words. Now, there's a problem here. In every book you analyze, you'd find that these words are actually the most common ones. So these are articles like the and I, a pronoun. So these words are found everywhere. So we need to figure out a way to ignore such words, and these such words are known as stop words in natural language processing. So what I'm trying to say is that now we need to use some techniques known as natural language processing. So techniques which Python uses to recognize language, basically. So these techniques are able to find that this is an article. So these are like intelligent techniques, and they ignore these articles and they can give you the actual words which are not articles, so which are not stop words. In other words, we need to filter out the stop words. But that is something you learned in the next videos tomorrow. So that will be natural language processing. Today we focused on regular expressions, and that's about this video. Thanks a lot, I'll see you later. Right, you learned what irregular expressions are, but to make sure you know how to use them on your own, you need to use them on your own. So that's why we have exercise. So welcome to today's exercise. In this exercise, you will be using regular expressions to extract certain information from the book Miracle in the Andes. So let me explain you what exactly you need to do. The first thing is, of course, to load the book, and I'm showing you the code already because We have done this already, so there's nothing new here. Once you load the book, you need to write some code which prints out a list of paragraphs. The paragraphs that contain the word love. So a paragraph is a bunch of sentences. And so previously we extracted sentences that contain love. Now you need to extract paragraphs that contain love. So the output would be a list of paragraphs where each paragraph is represented as a string. So the output would look something like this. So a list of paragraphs. So that would be the first string representing the first paragraph, which contains love somewhere in here. Then we would have the second paragraph, it's also a string, and so on. So that's the expected output. Then we have the other task, extracting the chapter titles. The output for this would look like this. So you should return a list which contains the titles of the chapters. You know, the titles are here. For example, chapter 1 has this title before. Then you have chapter 2. Its title is Everything Precious. So all these titles, as you see now in this preview here, are as strings inside a list. So all the 10 titles, right? Then the next one is you need to write a function which finds the occurrence of any given word. So basically I have defined the function here, and then I can call the function like this. So find is the name of the function I defined in this hidden cell. So find now gets any word as input, for example love, and if you execute that, it should return the number of occurrences for that word in the book. When a word doesn't exist, for example, the book doesn't ever mention the word hate. In that case, you should return this message. The book does not contain the word hate. So whatever the user enters there, you should reflect it in here. So that's the case when there are no occurrences. And that's about this exercise. So good luck. See you. Hey, in this video I'll show you my solution to the tasks I gave you in the previous video. So this is what I did. I loaded the book here. Then to extract the paragraphs where love was used, I used this code. So let me explain you the code here, what it does. So basically, you need to understand what a paragraph is. So if you look at this text file where the book is, you'll see that this is a paragraph, and paragraphs are split by break lines, and break lines in Python are represented as \n. So this represents a paragraph. This pattern matches a paragraph which contains love. So basically we're saying give me any string which has love, and it should not have \n. So this is a negation, this symbol here. So it should not contain \n one or more times. In other words, this will match any letter, any character, but break lines. So break lines will not be counted. And same goes after the words love. So anything will be matched, spaces, commas, other characters, but not break lines. And that should give you the findings list. So I've just printed out just the first two paragraphs here. So a list of 2 paragraphs, but there are more, of course. I just didn't want to show them in here. Extract the chapter titles. This can be done in 2 ways, and this is very important because you learn a new concept about regex, regular expressions. So the first method, which is more primitive, is this. So we're looking at capturing these pieces of text, right? Everything precious. That's a title. So the secret to match this from the text is that you should see what makes this special, this text special from the other text. And what I found out is that the text is always in letters. It doesn't have any periods. It might have commas though, so you could have a comma here, so you could add a space and a comma, because the chapter titles can contain spaces, but sometimes maybe they can contain a comma as well. But they don't contain periods, so I'm not adding a period here. So if I execute this, I get this list of chapter titles, and then they are followed by 2 break lines. So 2 break lines after this, 1 and 2 here. So that pattern will match actually these, but together with the \n. So this line here, which if I remove that, I'm going to get these together with these \n. So you might ask, well, we don't need to capture these, we only need to capture the titles without the \n. And then the other method does a better job on this, but if you don't use the other method, which I'll explain in just a bit, you'd have to strip out the titles, so the findings list of strings, you need to strip it out of these \n using a list comprehension. And then the new findings will be those without the \n. However, there is a better way to do this. Again, we import RE, and the pattern is the same as this, but it does have a very crucial difference. I have placed this part around parentheses. You see an open parenthesis here and a closing parenthesis here, and \n are outside of those parentheses. That means that tells the compile method to return only the part inside the parentheses. So in other words, the round parentheses tell Python to only get these in the returned findings. So these 2 are just to indicate what is after that expression, but these are not included. So everything that is outside the parentheses serves as a pattern, but it's not included in the result. So that's the better way to do this. Of course, I didn't expect you to do this way, but this was a great opportunity to learn this method as well. Great, then a function which finds the occurrences of any word. Basically, this consisted of putting together the code you learned in the previous videos, putting together that code inside the function. So that's a function, it gets 1 argument, w, then we construct a pattern here. So this represents any word, any bunch of letters in a row, any bunch of letters one after the other. And so then we get the findings, then we calculate, we count how many words we have, how many occurrences we have for each word, and return the dictionary in here. But we only return the dictionary if the word is found, otherwise we return the string. So an F string where we inject the words that the user entered here. So it's basically the same code that we used before, plus this try except block. And then I'm calling the function here, and we get this result. So that's the complete code for the exercise, and I hope this makes sense to you. If you have questions, drop them in the Q&A. Thanks, see you.